Hi, welcome to the Calculus 3 assignment practice series. We are in the unit vector calculus, and this will be our fourth homework assignments about the line integrals. And we're going to divide this into two videos, just like we did for the lecture. So for the first video, and I'm going to show you how to do several problems on the line integrals over the scalar field. Okay, then the second video, we're going to work on some practice problems and how do we do the line integrals over the vector field. Okay, so now let's go ahead to take a look at our worksheets here. And okay, so this is our homework assignments worksheets about the line integrals here. Okay, so now let's go ahead and get started. Okay, so the first, let me see here. Okay, so the first problem and the second problem, the first two problems are pretty straightforward because it has already defined these curves here, right? So the C, this given curve, C is here, is already defined in the parametric form for you. So you can just directly plug it into the formula and get it. Okay, now the first things here I want to show you is let's take a look at the problem number 3 here. So I want to do the line integrals from the, this given C, and the C is the right half of the circles here. It's x squared plus y squared equal to 16 here. And so take a look here, right? So this is a ds here. That means I'm doing the line integrals over the arc, this half circle. So let's take a look at what is this half circles looks like. So this is 2, this is 2, this is negative 2, right? So that means I am integrating here. It's the right half, right? So this is the right half. So I'm integrating, this is my C's here, all right? And so as you can see here, it does, this problem did not give us the parametric form, but from the calculus or the, when you were in high school, the pre-cal, you know how to define the circles, right? So here, this is the, so I can define, I can say X, because this one here is what is 16. Oh, I'm sorry, 16. So here is 4, here's 4, here's negative 4. So I can define the X is equal to the 4 cosine t, and y is equal to what? 4 sine t. This is our typical way when we defined circles here, right? And now my t is starting from here and I'm moving my t. So that's why this is how my curve traveled. So here, what is the angles here? This is what? Negative what? Pi over 2. So I know my t is started from the negative pi over 2 to what? To the positive pi over 2 here, right? So that's the first things we need to be careful about how do we define the t ranges here. Okay, so now let's take a look here, right? Okay, so now I have the x prime t. So this will be negative 4 sine t. And I have what here? I have y prime t. So this is 4 cosine t, right? Okay, so now I can substitute this line integrals kind of to the t. So what is my t's here? My t's range from negative pi over 2 to the positive pi over 2, right? Now I placed my x value. X is 4 cosine t, right? And then the y is 4 sine t, okay, to the 4th power, okay? And now I have square roots inside because I have ds, but the orthogonal will be the x prime square plus y prime squares, right? So x prime square is negative 4 sine t to the square plus 4 cosine t to the what? To the squares, right? Okay, so now in here, okay, so then what here? We change to dt. So we change the whole thing to a single variable, t. Okay, so then the integration should be pretty straightforward. So this will be the negative pi over 2 to the pi over 2. So this is a 4 to the 4th power. So here I have a 4 to the 5th power. I have a cosine t, and I have a sine 4 t here. Okay, so then look at the inside. This is pretty cool, right? So this is 16. So in here, I love those sine square, cosine square, right? So this is a 16 sine square t plus 16 cosine square t. So I know the whole thing's here because sine square plus cosine square is by Pythagorean theorem is 1. So this whole thing becomes the 16 inside. Then you take the square roots of what I have here, 4, right? All right, so this one's become pretty easy here. This is a dt. Then we know this is pretty cool. So this is a sine, so you use u sub, and so the sine, so if you do a simple u sub, the u is equal to the sine t, then the du will just be the cosine t dt. So this one is, then you'll be able to integrate very easily. So I have a 4 to the 6th here, right? Then you have the u to the 5th power. So u to the what? 4th power. So you will say this is 1/5 and the sine 5t here, right? So from the negative pi over 2 to the pi over 2, right? So here, right? So that's why after you substitute here, then this side inside here will just be like a 4 to the 5th and 4 to the 6th, and then you have a u to the 4th du's, right? That's how do I get this integration. I assume you know very well how to do this. Okay, so then the answers here, this will be the 4 to the 6th times 2 to the 5th here. So if you put it into the calculator, you can get approximately 1638.4 here. Okay, so the purpose I'm showing doing the problem number 3, the main purpose is of what? Showing you how do you define your parametric forms here. Okay, now let's take a look. Okay, so another one here. It said, okay, I'm going to, okay, so try to do these integrations, and these curves here is the arc of the curve y equal to the square roots of the y equal to the square roots of the x here. So let's say this is 1, 2, 3, 4, 1, 2, right? So we know that x equal to 1, y equal to 1. This is, okay, and then y, x equal to 4, y equal to 2, right? So this is the what? This is my c here, correct? Right, so this is my c. I'm going to integrate. So this is my curves here, all right? And then in here, this is the point 1, 1. And this is the point what? 4, 2 here. Okay, and now in here, they said, okay, so be careful here, right? So in here, what I have in here, this is a dy. So it's not a ds anymore. Okay, so let's take a look. How do I do this one here? Okay, so y equal to the square root of x. So I can still do, this is x equal to what? I can assign the parametric t. Can I? Yes, I can assign parametric t. And so what is my y going to be? Y is going to be square roots of what? Square roots of the t. Okay, and then now the x prime t is equal to what? Equal to 1. So what is the y prime t here? It will be the 1/2 square root of the t. That's right. Okay, so now let's try to put this into the integrations here. So then this one's here, right? Okay, so it's a c here. I change it to the parametrics here, right? So x squared. So what is here? This is t squared. y cubed. What is y cubed here? This is t to the what? 3/2, right? And the minus here. Okay, so minus, this is t to the what? T to the 1/2, right? Okay, this is 1 minus t to the 1/2. Okay, so be careful. Here we said this is dy, right? So I need to use y primes here. So this is where we need to be careful here. So y prime is what? This is the 1/2 square root of the t, right? Now I'm integrating from what here is the dt here, right? Okay, so now here, that's why this part you need to be careful, right? Because this is a dx. And then the next thing here is, okay, t, so where is my range t? Because I have defined x equal to t. So my t is vary from the x components, right? So my t is vary from what? 1 to the 4th here. Okay, so now if you simplify these ones here, you can basically this one will be simplified to the 1/2, 1 to the 4th. If you move the square roots of t inside, you simplify to a pretty easy one. So it's a t cubed minus 1 dt. I believe everybody know how to do that, right? So then these ones here will just be 1/2. What is here? So this is t fourths over 4 minus t. And here is from 4 to 1 here. So the answer is pretty close to the 30.375 here, right? So for these two problems, basically I'm showing you how to set the parametric equations, right? Okay, now let's take a look. The next one is very interesting one. I'm going to do number 8 here. Number 8 and the number 10 for you, see here. Okay, so number 8 here. This is the one, let's say here. Hey, so this one's here, the C, I'm integrated over C. But this C is included the two pieces, right? So one is the arc of the circle from the 0 to 2. Then after that, I have a line segments from the 02 to 43. So that means that the C is the combination of the two smooth curves, right? So let's try to take a look. What is this curve? What is this C looks like? Okay. So the circle is 1, 2, right? So this is 1, 2, 3, 4, 1, 2. Okay, x squared plus y squared from 2, 0 to the 0, 2. Okay, 2, 0 to the 0, 2. So that means this is my curve, right? From the 2, 0 to the 0, 2 here. So what is this one here? I can call this is C1s, right? So you go from here. Okay, then the next one is a segment, right? A segment from the 0, 2. So it's start at this point to 4, 3. So 4, 3. Okay, so 3 is here, 4 is here, right? So 4, 3. Okay, so this is the segments. I can say this is what? It's a C2s, right? Okay, so from the 0, 2 to 4, 3. So this point, this is a 4, 3 here. So now I'm going to do the line integration over the C1 and the C2s here. Okay, so now let's try to see. Okay, so we need to separate that. So let's try to do this. I said, okay, for the C1s here, okay, so for the C1, let's define the what is this parametrics, right? So this is the C1s here. This is my C1s, right? So this green one is my C1. Okay, so it's a circle. So as always, the circle is easy. I can say x equal to 2 what? Cosine what? Cosine t. And the y is equal to what? 2 sine t. Easy. Okay, so x prime t is equal to what? Negative 2 sine t y prime t is equal to the 2 what? Cosine t. Okay, good. Now let's take a look at my C2s here. So my C2s here, right? So first, let's try to find this line. So this line passing 0, 2, and 4, 3. So this line you can find is y is equal to the 1/2 of x plus 2, right? Okay, so now 1/2 of x plus 2 here. Okay, so now let's try to define the parametric for this ones here. Okay, so I can assign the x equal to what? X equal to t, correct? Okay, so if I do the x equal to t, so what is my y here? My is 1/4 t, what? Plus 2, right? Then the x prime t is 1. Y prime t is what? 1/4. Okay, now let's try to do the integration. So from the previous, I need to integrate, over each ones here. So the first ones here, I separated these ones, right? So I can separate this one to a C1 plus C2s here, right? And one thing is here, be careful, this is dy's here, okay? So we need to pay attention to that. All right, so now the first C1s here, right? Okay, C1s here. C1 is here, right? Okay, so C1, so my x equal to the 2 cosine t. So I have a 2 cosine t, what? To the square. Am I right? Okay, so in here, this is dx, right? So this is a dx, all right? So the dx, oh, where is the dx? It's here. So I have a -2 sine t, all right? And change it over to t's, right? Now plus x squared. What is the x squared here? So I have the, so this is x squared, so plus, I'm sorry, so this is y squared, right? So y squared is 2 sine t squared. But here, this is dy. So what I have here, 2 cosine t dt. Okay, so this is C1, right? So this is all integrating under the C1. So C1 is go like this. So from 0 to what? 0 to pi over 2, right? So this is the C1. After I finish the C1, I need to add the integration I do for the C2s here, all right? So the C2s here, let's take a look at the C2. So we know C2 is this path, x equal to t. Am I right? Okay, so it's a t squared, right? So I said x equal to t, so I have a t squared. Okay, t squared dx, what is here is 1, right? So it's 1. Then, I better put it here, the whole thing is dt, right? So then plus y squared. What is y squared? Y squared is 1/4 t plus 2, the whole thing square. Then here's dy. So what I need to do here? 1/4. Okay, now I finally, this is d2. And so now this one's here, this is the integration along the curve C2. And now, because I defined t is equal to the x, so what is my ranges here? X is from where to where? From 0 to what? From 0 to 4, so here. And so now I change everything into a single variable, the dt. So you just need to do the integration twice. And so instead of not wasting time here, I assume you all know how to do those one variable, typical calculus 2 type of the integration. So overall, the answer I have is 83/8. Okay, all right. So now let's take a look, one more. Okay, so in here, this is the number 10 here. So let's take a look here. First thing is, oh, this is, I want to do the line integral over the arc length. All right, so this is the line segments from 312 to the 125 here, right? So first, I need to define the line segment, right? In R3. So back to what we learned previously. So the directional vector for this line segments will be what? Will be 1 minus 3, negative 2, 1, and 3, right? So I can define my x here. I can choose this pointer. So I can define so x is equal to what? 3 minus 2t. Right? And y is equal to what? 1 plus t. And z is equal to what? 2 plus 3t here. Right? Now, the key things here is, if you still remember, we said for the line segments, right? If you don't define the value of the t's here, it will just be, the line continue to go. If you want to limit the line between these 2 points, that's why I call the line segment. So if you remember, so what is the t value? T is between the 0, 1s here. Okay, so t will be between the 0, 1s here. So now let's try to do the integrations here. All right. Okay, so because I have a ds, right? So I need to use the x prime t. So let's take a look at x prime t is equal to what? Negative 2. Y prime t equal to what? 1. Z prime t equal to what? Equal to 3, right? Okay, so now this one's integration, I can change that. Okay, y square, what is y square? So it's 1 plus t to the square times z. So what is z? 2 plus what? 3t. Okay, because this is a ds, so I need to use what? X prime t square plus y prime t square plus z prime t square. So x prime t square is negative 2 square plus y is 1 square plus t is 3 square. Now it's dt, right? So the key things here, your t is from 0 to 1. And then the same way you can, so because this square root is a constant, right? So it's pretty, it's pretty easy. You can just expand it and FOIL it, right? So I think I got this one. So this one is 14, right? That's inside the square roots. Then this will be 0, 1. And when you FOIL it, you will get a 3t cube plus how many? So the plus like a, so it's 1 plus t square, right? So you FOIL this term. So I got a 3t cubed plus 8t square plus 7t plus 2, right? So become a simple calculus 2 type of integration. And the answer I have here is 107 over 12 and the square roots of the 14. Okay, all right. So I did this 4 problems for this assignment and to help you get a head start for how to do the line integrals over scalar field, right? Like I mentioned, the hardest one, if they already give you the parametric form, then it's pretty easy. The hardest one is how to define the parametric form for your curves here. All right, I hope that this help you to start to do this assignment. Okay, nice to talk to you. And so we're going to talk, I'm going to talk to you on the next videos. Okay, bye. Have a good day. Bye-bye.